for our second further explanation. Solve the separable equation with two initial values here, t of 0 given, t of 4 given. Yeah. The reason is very simple, because k is unknown. The decay constant little k is unknown. T, the function, temperature function, unknown. Constant, decay constant k unknown. So we need two initial conditions. All right, now let's move to the computation part. I need some space to do the calculation. All right. Here in this one, although this equation is pretty easy to solve, but there is one problem I like to spend some time to explain. That is, remember the absolute value question. We need to determine, we need to find a good way to handle that absolute value situation. Yeah. All right, so let me show you the details. Yeah. All right. So here I need to change my pen color. Yep. This one. All right. Yep. All right. Yeah. It's a separable equation, so solve this one. Pretty easy, straightforward. We can write the separable version. K, we can put it together with dt. Yeah. Then we take integral both sides. Yeah. And yeah. Many of you may like to use the variable substitution. Yeah. Because this is pretty easy. So if you can do it without variable substitution, that's good. All right? Yeah. So here, yeah, because most students still like to use this way. Yeah. Now, du equals dt, so we get to the u version. Du over u equals kt plus c, right? Yeah. Then natural log absolute value of u equals kt plus c. Yeah. And we know u is this one, so we have, let's write another step. Natural log absolute value of t minus 45 equals, still kt plus c. All right. Here, now we want to remove the absolute value. Remove the absolute value. But here, in this question, I want to take a different way than our previous one. The previous one, if you go back to take a look, you can see we did a lot of analysis to determine the expression inside the absolute value is positive. Sometimes we can do it, but sometimes it is hard to do it. Yeah. For this question, we have the problem. For this question, it is hard to determine if t minus 45 is positive. Yeah. Yeah. It may not be easy. Yeah. So here, there is a situation. Yeah. It is not easy to determine the expression inside the absolute value is positive or negative. Yeah. Yeah. So don't worry. Yeah. In this situation, in this question, I want to use this example to show you we can get around it easily. We do not need to. spend a lot of time to do analysis to see if the expression inside the absolute value is positive or negative. Yeah. We can get around it using another way. Here I show you another way. Okay. All right. Let me write one more step. Remove the natural log. So absolute value t minus 45 equals e to the capital C times e to the kt. Okay? Yeah. All right. And here now, I need to remove the absolute value. When I remove absolute value, I may have positive case or negative case, right? Two possible cases. I may have two possible cases. Yeah. Now, I want to write an expression that can cover both cases. Cover both cases. Yeah. So let me show you how to write. Yeah. T minus 45. Okay. Yeah. T minus 45. Absolute value sign is gone. Yeah. But the right hand side, then because I may have positive case, negative case, and e to the c is a positive number, right? E to the c is always a positive constant. Yeah. But now I want to replace it by another constant. Let me use A, capital A. A here could be positive, could be negative, right? Yeah. So if you take negative, yeah, no problem. In my A could be negative. If it's a positive, my A could take positive number. So capital A times e to the little kt. Yeah. In this way, we can get around that absolute value problem gracefully, right? Yeah. No loss. No loss. Yeah. Gracefully. All right. Then we can plug in two initial values, first one, second one, to get information about little k. Yeah. The first one, t of 0 minus 45, k times 0, that's 0. E to the 0, that's 1. So equals 8. Right? Yeah. T of 0, 70. So you can see A equals 70 minus 45, that's 25. A is a positive number, 25. Okay? All right. Yeah. Let me use the space here to complete the remaining calculation. Yeah. All right. So now our t function, we can write explicitly 45 plus 25 times e to the kt. K is still unknown, right? Yeah, k is still unknown. Yeah. So let us plug in the second initial value to get information about little k. Yeah. So t of 4 equals 45 plus 25 times e to the 4k. 4k. Okay, all right. 65 here. Yeah. Then we have e to the 4k equals 20 over 25, right? Yeah. Simplification, 4 over 5. 4/5. Yeah. E to the 4k equals 4/5. Yeah. You can solve this equation for k, right? Yeah. So you can find k equals by some calculator. Yeah. But we do not have to. Yeah. We do not have to do that calculation. Yeah. Remember, we did before, because when you calculate explicit value for k, you may have certain error, right? You may have certain error. Yeah. Here, we want to avoid that error. So we do not do that calculation. So we keep this. E to the 4k equals 4/5. Yeah. All right, now let's go to our destination, because our goal, we want to calculate T of 8. What is that temperature at time point 8, 2 a.m. Yeah. Equals 45 plug in 25 times e to the 8k, right? Yeah. kt, t equals 8, so 8k. Yeah. All right. Then equals 45 plus 25. How about e to the 4k square? Yeah. 8. We split 8. 8 equals 4 times 2. So based on some algebraic property, yeah, that is e to the 4k parenthesis square number. But this number, we know it, right? Yeah. So 45 plus 25 times 4/5 square. Okay? Yeah. So 45 plus 25 times 16 over 25, right? Yeah. So cancellation. Yeah. 45 plus 16, 61 degree Fahrenheit. Yeah. A nice number, integer. Yeah. Not very messy. Yeah. Think about, if you calculate little k explicitly, then you plug in here. Yeah. Although I believe you can get the same answer, but you may have some small possible error, right? Yeah. Very close to 61, yeah, but you may have some small error. Yeah. In this way, we can avoid error. Okay? All right, so we complete those 2 further explanations in our lecture module 1 part B. Yeah. So let me stop right here.